In this video, we're going to solve a word problem to find a limiting reactant. Just to review, limiting reactant is used up completely and it limits the amount of product formed. Therefore, when we perform the calculations, the reactant that produces the least amount of product, that is the limiting reactant. If you would like to find out more on limiting and excess reactant, you may want to check out a video that I've posted in this series. I'll place the link in the description box below. Let's find the limiting reactant when 10 grams of sucrose combusts with 10 grams of oxygen to form carbon dioxide and water. First thing first, we need to write out a balance equation, and we do that by putting together what the question gives us. So we have C12H22O11 for sucrose plus O2, because oxygen is a diatomic molecule, gives us CO2 and H2O. Now we balance the equation by placing 12 in front of O2, 12 in front of CO2, and 11 in front of H2O. If you need a recap on how to balance the equation, I'll place the link in the description box below. Now that we have a balanced equation, we are ready to find the limiting reactant. In order to do that, we need to know, starting from 10 grams of sucrose and 10 grams of oxygen, how much of the product will be formed. Based on what we know, limiting reactant limits the amount of product formed. So we'll just simply use one of the products, say CO2 in this case. You can calculate for H2O if you want to, but I'm just going to use CO2 because it's one of the product. So what we're going to do is we're going to calculate how many moles of CO2 can be formed. So we start our calculation from 10 grams of sucrose, which is C12H22O11, and then we convert from grams of sucrose to moles of sucrose. From mole of sucrose, we can then easily convert it to mole of CO2. So this is our plan, and it's going to take us 2 steps to execute. Let's go ahead and calculate. We start with 10 grams of sucrose, and we multiply, draw a line across, and we're going to place grams of sucrose at the bottom so that it will cancel off. And since the first step, we're going to find the mole of sucrose, we're going to place that on top. And then we need to look up the molar mass of sucrose. We add up the atomic mass, multiply with the appropriate number. That's going to give us 342.3 grams for every 1 mole. For molar mass is always for 1 mole. And now we're ready to move on to the second step, which is to find the mole of CO2 from the mole of sucrose. And to do that, we're going to place the mole of sucrose at the bottom so that it can cancel out. And then we're going to place mole of CO2 on top because that's what we want. Now, in order for us to find the molar ratio, we need to refer to the balance equation. That's why the first thing we did was to write the balance equation. So if you look in the balance equation, the number in front of CO2 is 12, whereas the number in front of C12H22O11, which is sucrose, it's nothing, there's no number. So if there's no number, it means that we have 1. So we plug in those numbers into our equation. So we have like 12 in front of mole of CO2, 1 in front of mole of C12H22O11. We do the math, we take 10, divide by 342.3 times 12, and that gives us 0.351 mole. That's the amount of CO2 that is produced from 10 grams of sucrose, which is C12H22O11. Now let's do similar calculation, but this time we start with 10 grams of O2. The plan is just the same, except for now we go from 10 grams of O2 to moles of O2, and then from moles of O2 we find moles of CO2. It's important that we calculate the mole of the same product like the one that we did for sucrose. So since we calculated mole of CO2 for sucrose, we need to find the mole of CO2 for oxygen. Otherwise, it's like comparing apples and oranges. Let's calculate the mole of CO2 starting from 10 grams of O2. We multiply, draw a line across. We place grams of O2 at the bottom so it cancels out. And then after that, we place mole of O2 on top because that's what we want in our first step. And then we go to the periodic table, look up the atomic mass for oxygen, and multiply by 2. So that gives us 31.998 grams for 1 mole of oxygen. Keep in mind, molar mass is always for 1 mole. Regardless of what number you see in the balance equation, in this case it's 12, don't worry about that. 1 mole of O2 is always 31.998 grams. And then we multiply, draw a line across. Now we want to get rid of mole of O2, so we place that at the bottom so that it cancels out. And then we place what we want on top, which is mole of CO2. Now to get the mole ratio, we just refer to the balance equation. So we have 12 in front of CO2, and we also have 12 in front of O2. So we're going to put 12 in front of those two values, and that gives us 0.312 mole. That's the amount of CO2 that is produced from 10 grams of O2. Since limiting reactant is the reactant that limits the amount of product formed, that means the reactant that produces the lesser amount of CO2 will be the limiting reactant. In this case, it must be oxygen because oxygen only forms 0.312 moles of CO2, whereas sucrose forms 0.351 moles, which is more. To recap, in order to find the limiting reactant, we need to first start out with a balance equation, and then we convert from the given information to find the mole of one of the product. And then we do the same thing for the other reactant to find the mole of the same product as well. The reactant that forms the least amount of product, that is the limiting reactant. Quick summary, when figuring out the limiting reactant, we first need to write out a balance equation. From the given information and the balance equation, we're going to use that to find the mole of the product from each reactant. The reactant that produces the least amount of product, that's the limiting reactant. Now, important note that I want to point out is that in step B, we must convert from the given information for the reactant to the mole of the product. If you only calculate the mole of the reactant, that means you only do the first step, you may get the wrong answer, depending on the question. So keep in mind that you always convert from whatever information that you're given on the reactant all the way to the mole of the product. And with that, we're done finding the limiting reactant using an example. There are other videos in this series on empirical and molecular formula, percent composition, intro to limiting reactant, percent yield, and percent purity. I'll place their links in the description box below. Be sure to check them out. Here's a video that I've handpicked for you. Do check out our app that's available in both Google Play and App Store. Thanks for watching all the way till the end. If you find this video helpful, be sure to like and share it with someone. Don't forget to subscribe and hit that bell icon so you won't miss future videos. Your support means a lot to me.